Welcome, my dear class 11th standard students, be it 2026 or 2027. Welcome aboard, welcome aboard, welcome aboard. This is your Captain Shreyas, your physics master teacher, and I have been in this journey again and again with multiple students, thousands of students over the last 13 plus years. And here again, we start with the first class of 11th standard with the basics of kinematics, where you learn like a bridge course, you can say, where you learn about all the fundamental basic concepts. Don't worry, we are going to also do kinematics as a separate chapter, but this will level you up with a lot of things which you might have forgotten from your 9th and 10th, right? So let's gear up. And well, my quick introduction would be I have done my graduation from NIT Nagpur long time back. When I wrote my JEE, I almost got full marks in physics when I wrote my JEE advanced paper. That time it was called mains and all, it was subjective. And yes, I did my research from IIT Bombay. So here I am to make sure that I am with you for the next 2 years till you crack the JEE 2027. And if you're a 12th standard student wanting to cover up your basics, you're starting from the scratch, obviously nothing better than this class. So quickly smash that like button and also hit the subscribe button right away, right now. Okay. And I hope I'm audible, visible, live. Yep, for everyone out there. Okay, looks like I am. And where is this? Where is this? Where is this? Okay, there we go. Good evening, good evening, good evening. Are these one-shot sessions? No, these are not one-shots. These are basically, we are starting with the bridge course. I made an announcement yesterday for 11th. For 12th, we are starting with chapter 1. Chapter 1 of 11th standard will be starting after next week, where you start with units and dimension and so on and so forth. Okay. Bridge course is mandatory because you would have forgotten a lot of things. It will level you up so that your first day will not be a bouncer. Okay. And let me know whether you are in class 11th or class 12th or a dropper student. So we have dropper students too and a lot of 12th standard students too. Welcome. Yes, a 12th standard student can watch this if your basics are not clear. But if you're okay with your basics, then you can skip this class. But if you feel you want to revise, definitely you can watch it. Okay. If it is clear, then no need to watch. All right. So let's begin with the journey. And I hope you have smashed the like button. And if you're not yet subscribed, subscribe to the channel, guys. Okay. And for those of you who do not know, this year we had amazing results in JEE Advance. All India rank 15. Daksh, he's also Olympiad scholar, represented India. All India rank 15 in JEE Advance. He got 120 out of 120 in maths. And so many other toppers, even KCD toppers, even board toppers are there with amazing percentages. So they not only did well in JEE Advance, but also in the boards and other examinations. Be it Prakhar, All India rank 92, Panini 273, Anubhav 390. So many students under top 1000 rank. In fact, 1 in 3 Vedantu students have cleared the JEE Advanced examination. So you should be proud that you are starting with a very high probability the moment you are in Vedantu. Okay. So when we talk about kinematics, when we talk about kinematics, when we talk about kinematics, we usually talk about, how things are happening, where are the things happening, where are you right now, when are you going to do this, when are you going to reach there. This is how you basically can understand kinematics. Kinematics is the study of how, where, and when things are happening around us with regards to the motion of a body, with regards to the motion of a body. And physics always has to do with something which is moving. If everything is at rest, not moving, it is no longer fun. When things are moving, they are rotating, when things are vibrating, oscillating, something crazy is happening, then only you will be studying it. So that's what is kinematics all about, of the study of the motion of when, where, how, etc. Now, there are a lot of things that you should consider when you talk about, all these parameters, how, when, how, where, etc. Like you have distance, you have displacement, you have velocity, you have acceleration. You might have forgotten a couple of these things. So don't worry, we will quickly revise these things. Okay, yes, it will be posted. The PDF will be posted in the description box as well as in the comment section. so that every time the session is over, you will be able to access it. It will take normally 1 day for the PDF to be live, okay? Because we'll post it as a link. We cannot just put a PDF in the comments. YouTube does not allow that. So we have to make a web service link or a cloud link. So it will be uploaded on our servers, and that link will be shared to you, because how else will I be able to share? Okay, cool. So let's talk about first position. Let's talk about the word position, because this usually comes in kinematics. Position means where are you? Where are you? Or basically that particular body, or basically that object which you are considering. So that is essentially position. Okay, what is the location, where, or basically the location of that particular body, or you, or the person, whatever that object that you are looking at. So usually the symbol for position, is r. But whenever you are moving only along one dimension, either in this left or right, or up and down, or towards you and towards me. So if you are moving in only a straight line, then we don't usually use the symbol R. So I will put it up over here. The usual symbol, is basically R. But in one dimension, usually we use X or Y or Z. X or Y or Z. You tell me the coordinate, X coordinate or Y coordinate or Z coordinate. Do you remember coordinates? Basic coordinate geometry you would have learnt in 9th and 10th standard. Yeah, you just tell me where you are. For example, imagine, wait a second. Yes, imagine, this is your X and Y axis. Z axis also can be drawn. Chumma, I've just shown X and Y axis for now. Imagine there is a Pandu. Who is Pandu? Pandu is our friend. He helps us understand physics very nicely. This Pandu is over here. And I can see he's standing on the X axis. So if somebody asks me what is Pandu's position, I'll check the coordinate. Okay, X is 1, 2, 3, 4, like this. Oh, X is equal to 4 meters is Pandu's position. Is basically Pandu's position. Everybody with me? Is basically Pandu's position. So because I can see Pandu is on the x-axis. Let's say after some time that same Pandu will move to some other new position like this, and that same Pandu is now over here. That same Pandu is now over here. So what is the new position? I will check the coordinates. 1, 2, 3, 4, 5, 6, 7, 8. Oh, x is equal to 8 meters is the new position. Is the new position of Pandu. Is the new position of Pandu. Everyone with me? Everyone with me? Understood? Oh, clear? Oh? Similarly, imagine there is a beautiful Champa. Champa is also our friend, and she is maybe Pandu's girlfriend also. So beautiful Champa is standing at the origin. So I can say that Champa is right now at the origin. So Champa is at the origin. That is Champa's position. Maybe Champa will move after some time, and maybe Champa might come over here, or maybe she might go down. Who knows? So let's say Champa goes over here after some time, and you check the coordinate. So maybe X is equal to 5 meter is the new position of Champa. Is the new position of Champa. So that is why whenever somebody or something or some object is moving along one line, then either the X or the Y or the Z coordinate is enough. but we will study 3 dimension later on. We don't have to break our head right now. This is the basics class. So this is how you mention the position of the particle. Everybody with me? Understood? Clear? Okay, sir. Now, what if I can tell you the position in a graph manner? Yes, I can tell you the position in a graph manner also. Sir, how, sir? Can you tell me the position in the graph manner? Observe this carefully. Observe this carefully. Let's say this is the x coordinate. Let's say this is the time. Let's say this is position versus time. This is a graph. So this is a graph. This is a graph of position versus time. Position with time. And let's say I draw that graph something like this. Let's say I draw that graph something like this. It starts like this, goes up, okay, nothing over here and over here. And maybe I start marking some lines, important lines. Okay, very important lines. I start marking over here. Okay, something like this. And yeah, maybe this is 1, this is 2, this is 3, this is 4, this is 5. Maybe this is 2, maybe this is 1, maybe this is 3, maybe this is 4, maybe that is 5, and so on and so forth. Okay, something like that. What does this graph tell you? It tells me where was that object at which time. At 2 o'clock, where were you? At 1 o'clock, where were you? At 1:30, where were you? So, let's say you come back from school and you don't come early, then your mom or dad will ask, where were you? What were you doing? Then you tell, Papa, Mama, I was there, then I went there, then I went here, and then I did this. But because you're my captain, Shreyas sir student, you can draw a graph and show. Mama, Papa, I'll tell you, wait, I'll draw a graph. Oh, they will only get confused. What nonsense? He's learning a lot or what? So you can draw a graph and tell where were you at what time. So can you think what must be that person doing in this particular process? So he was definitely only going in the x direction, because this is x coordinate versus time. So only his x coordinate was changing. He was moving along the x axis. So I will show the x axis over here. So let's say this is the origin. Let's say this is 1 unit. Let's say this is 2 units. Let's say this is 3 units. Let's say this is 4 units. Let's say this is 5 units. As you can see, when the value of time was 0, when the value of time is 0 means what exactly? Initially. So this is also very important. Lot of people do not know this. So when I say t is equal to 0, it means initially. That means initially. So initially, what was the value of x? It was basically 2. So x was equal to 2. So x is equal to 2 is nothing but the initial position. Initial position of that body, the particle, the object, or whatever it is. Is this absolutely clear? Everybody understood? Everybody understood till this point? Okay, perfecto. So, 100% our Pandu or that person or that object, whatever it was here initially. That means that t is equal to 0. What did the person do later on? Let's try to think. Let's try to think, my dear students. That person slowly at 1 second, he was somewhere at 2.5 meters. At x equals to 2, sorry, at time is equal to 2 seconds, when time was 2 seconds. So after 2 seconds, you saw the person at x is equal to 4. Oh, so look at it. At time is equal to 2, the position was 4 meters. So that person was over here when the time was 2 seconds. So from 0 to 2, that person has moved like this. That person has moved like this. Are you able to visualize this? Are you able to visualize this? So from 0 to 2 seconds, that person went walking till 4 meters. That is what I got to know till this particular point. Okay. But then what did he do after 2 seconds? Oh my God, he stood there like a donkey. 2 to 3. X was same. It was 4, 4, 4, 4, 4 till 3 seconds. So from 2 seconds till what time? Till t is equal to 3 seconds. That person was there. Person didn't move. He was stationary over there. Yes or no? Very good. Very good. All right. All right. Perfecto. Now what? Now what? Next thing. Next thing. After 3 seconds, the person is moving till 5 seconds. But where is that person going? At 3 seconds, he was at 4. At 4 seconds, he was somewhere here. At 5 seconds, he was at origin. Oh my God, at 5 seconds, the person was back at origin. So that means that person would be over here at t is equal to 5 seconds. That means that person has traveled back crossing this point over here. Is this understood, guys? So what has the person done? At 0 seconds, he was already 2 meters ahead of the origin. Till 2 seconds, he went ahead. He went ahead and he stopped at 2 seconds and he waited for 1 second and then he turned back. He turned back and then traveled back to the origin at 5 seconds. That is what he has done. Understood this? This is how a graph can tell you what happened, or whatever happened can be converted into graph. Put a fire emoji if you understood till this point. Put a fire emoji if you understood it till this particular point. Perfect. Okay. So position is where you are, how you are, where you are, what is your location. Now, then, initially, after some time, it can be written down in words like this. Champa is at origin, Pandu is at 4 meters, Champa is now at this new location, or it can be shown in a graphical manner, or it can be shown in a nice graphical manner. Okay, that Pandu might be jobless. Very true. Very true. We have a lot of jobless Pandus. Now, the next thing that comes is distance and displacement. Distance and displacement. Observe this. So you have distance, 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 and displacement. Distance and displacement. Distance and displacement. You might have forgotten this, but I will remind you. Well, the usual symbol for distance that we use in our books is capital D or small d. Displacement, the usual symbol that we use is S, but you will see an arrow mark or a bar over it. That is perfectly fine. There is a simple reason for that, because this is nothing but a vector quantity. This, though, is a scalar quantity. It is basically a scalar quantity. Now, what is the difference between scalar and vector? If you have forgotten, let me remind you. When you talk about scalars, you just give me the magnitude. The magnitude means the value of it. The value of it. Whereas when it is a vector, you give me the magnitude and the direction. And the direction also. Both are mandatory. What is distance and what is displacement? Distance is nothing but the length of the path traveled. The length of the path which has been traveled. Don't worry, I will give you examples. Whereas displacement is a ray pointing to the current or basically the final position from the initial position. So you might be wondering, what is this, sir? Please explain. Don't worry, I will explain it. Imagine this is your x-axis. This is your x-axis. This is, let's say, your origin 1, 2, 3, 4, 5, 6, 7, 8, 9, minus 1, minus 2, like that, minus 3. Number line, basically. Okay. This is nothing but your number line on the x-axis. Example now, our Pandu was here. our Pandu was here. Okay, this is at t is equal to 0. Then our Pandu traveled somewhere just like before, and that Pandu traveled over here like this, and he reached over here like this. Okay, and he reached after some time maybe over here. This is maybe at t is equal to 2 seconds, just like that previous diagram. And finally, our Pandu, let's say he came back over here. Oops, this is Pandu's head. Oh my God. Okay, like this. This is, let's say, at t is equal to 5 seconds. Now, this was 2 meters. This is 5 meters. Chumma, I have put some numbers. Randomly, I have put. Okay. Okay. This could be 5 seconds or this could be 6 seconds. Anything, guys. It doesn't matter. Chumma, some numbers I can take. Okay. In this entire process, this Pandu traveled like this, like this, like this, went there, and he came back like this, like this, like this, and came back to the origin, isn't it? So if I ask you, what is the distance traveled? What is the distance traveled? What will your answer be? Think carefully and answer in the chat box. Okay. All right. Kevin, don't worry about that. Leave that planning up to me. Okay. Yes, you can definitely watch my Pathfinder, etc. But I would advise you to watch the newer series as much as possible, unless there is a class test or you urgently need to watch something. Okay. Yeah. So think carefully. Length of the path traveled. You moved 3 meters in the front, and from here to here, how many meters? 5 meters backwards. So 3 meters front, 5 meters backwards. So how much will it be? 3 plus 5, which is basically 8 meters. I have moved how many meters? 8 meters. Everybody gets this point. So from here to here, how much is that distance? Initially, that will be 3 meters. And from here to here, this length is nothing but 5 meters. So 3 plus 5 is nothing but 8 meters is the distance traveled. But if I ask you, what is my displacement? What is my displacement? Then you need to be careful. Yes, displacement is the ray. Ray means it has a start and it has an end with an arrow mark. It has a direction associated with it. It is a ray pointing to the current or the final location. This is the final location from the initial location. This is initial, this is final. So the ray will go like this. The ray will go like this. This is initial, this is final. So think about it. How much is this? This is only barely 2 meters. So this is barely 2 meters. But in this negative direction of x, can you see how is the arrow pointed? It is towards the negative side. If the arrow was like this, it would be positive. Is that right, everyone? So definitely this being the displacement, I will put it as negative 2 meters or 2 meters along negative x. Do you see the negative sign or the direction being mentioned along with the magnitude? Because it is a vector quantity. You need to tell me where, which direction also. Yeah, not just how much, but also the direction. Very good. Togo, Sanket, Ashwin, Abhijit, Ravi, Rock, Prasad. Very good, Vasuki. Yep. Awesome, awesome, awesome. Since this is a basic class, I am keeping the pace very normal over here. I know some of you might have done with some basics or already thorough with your 9th and 10th. So for you, it might be little slow, but there are a lot of students, guys, who might have forgotten a lot of things. So that is the reason why we are, covering everything. Now that you understand, okay, sir, this is distance and this is displacement. And can you now think and tell me which of the following options can be true with regards to distance and displacement? D, 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 S, 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 S. Okay, I'll put the symbols. Okay, one of them is correct. This is option A, this is option B, this is option C, this is option D. With regards to distance and displacement, come on, think carefully and answer in the chat box. No problem, Siva. Just start attending the class from now on, and maybe you will be able to answer the questions. If you're not, please rewind back and catch up within no time by playing it at 2x or 3x speed. Well, think like this. If there is a Pandu, if there is a Pandu, and that Pandu goes in a perfect straight line versus that same Pandu, okay, versus that same Pandu goes front, goes back, and again goes in the front like this. Here you can see my distance is equal to the displacement. How much is the path and how much is the displacement? Both are the same. But here my length of path is more, whereas the displacement is just a ray from initial to final, that will be less. So here my displacement is definitely lesser than the distance traveled. So this is also possible, this is also possible. So both are possible. So in general, what is the possibility, guys? In general, what is the possibility? Distance is more than or equal to the displacement. That means option C is the right answer. Option C is the right answer. Very good. C for your Captain Shreyas. C for your Captain Shreyas. Perfect. Amazing, amazing, amazing. Very good. Let me ask you the next question coming up on your screen. Which of the following are possible or not possible with regards to distance? Distance traveled is 0. Distance traveled is 0, is non-zero, is non-zero, and here we have displacement, which is basically 0, is non-zero, is 0, is non-zero. So there are 4 options out here. This is option A, this is option B, this is option C, this is option D. With regards to distance and displacement, multiple options can be correct. This is like JEE Advanced, where more than one options may be correct. Think about it carefully. Yeah, distance and displacement. Come on, think about it, my dear students. Distance and displacement. More than one options may be correct. Distance is 0, displacement is 0. Is this possible? Distance is 0 and displacement is also 0. Is this possible? 100% it is possible, my dear students. 100% it is possible, isn't it? Where you are at rest. So if you are at rest, you have not traveled at all. If you don't travel at all, then both of them will be 0. So A option is 100% possible. You have not traveled, but there is a displacement. Is this even possible? I don't think so. Yeah, I mean, look at it. I have 0 distance, but displacement is there. That means I have not traveled. How is it possible? I have not traveled. I have not traveled, but displaced. But I have displaced from one point to the other. Is this even possible, guys? Just think about it. From one place to the other, is it possible? I have moved, but I have not traveled any distance. This is impossible. So B is wrong, 100%. Okay, I have traveled, but my displacement is not there. Think about it. If I start from a point, I go forward like this, I go forward like this, and I take a U-turn, and I come back basically to my original location. I come back to my original location. In this process, I have traveled some distance, but there is no displacement. So 100% this is possible. What about the last option? Both are non-zero? Definitely. Let's say, for example, I move from this point to this point. In this particular process, 100% there is some distance and there is some displacement. So only B option was incorrect. Only B option is incorrect. Yes, King of Kings, correct. Togu Karot Kabijit, yes, Daniel, yes, Tena. Very good, very good. Excellent, excellent. Perfect, perfect. Now that you understand the difference between distance and displacement, it's time to move to velocity. It's time to move towards velocity. So, and speed, of course. So you have speed, speed, speed and velocity. It's very similar to distance and displacement. Just like you had distance and displacement, you have basically speed and velocity. Speed, usual symbol, you can use V. Velocity, V bar. This is a scalar quantity. This is a vector quantity. This is a vector quantity. That means you need to give direction. You, apart from the magnitude, you can also put V with an arrow mark over here. So that arrow mark or that bar always signifies that, hey, wait a minute, it's a vector quantity. It has direction information also. When I skip that bar, that means there is no direction information associated with it. I just need to worry about the value of that variable. Need not think about the direction aspect. So what is the definition then? So speed guys is nothing but how much distance you travel upon the time that you take, whereas the velocity is nothing but the displacement that you undertake upon the time that you take. Displacement upon the time taken. Displacement upon the time taken. Yep. Sir, is Sigma batch even for 11th graders? It says for class 12th and droppers. No, Sigma batch is only for 2026 aspirants, class 12th and droppers only. Okay. Yep. So that is what is basically your speed versus velocity. How fast you displace versus how fast you cover the distance. That is speed. So this is the formula for each one of them. Velocity is displacement by time, speed is distance by time. Anyways, you can see symbolically speed will be d by t. Here velocity will be displacement by the time taken. Displacement by the time taken. So say for example, we have something which goes over here like this, then comes back over here like this. This is x is equal to 1. This is x is equal to 3. This is x is equal to 5. This is t is equal to 0. Sorry, x is equal to 1 at t is equal to 0. This is at t is equal to, let's say, 4 seconds. This is at 4 seconds. So these are the values which are given to you. So essentially what has happened is that particle started from here, it went like this, took a U-turn and then came over here until it stopped over here finally. Is this clear? So 1, 5, 3. That is how the particle has moved along the x direction. If you ask me what is the distance traveled in this particular problem and how much is the distance, and how much is the displacement, what will your answer be, guys? Come on, quickly answer in the chat box. Distance traveled, I moved 5 meters. Then from 5 to 3, I moved 2 meters. Can you see? I have moved 5 meters in the front from, sorry, not 5 meters, my bad. This is 1, right? So 1 to 5 is 4 meters. 1 to 5, that is basically 4 meters. And from 5 to 3, that is basically 2 meters. So 4 plus 2, which is basically 6 meters I have moved distance wise. 6 meters, right? Everyone? Okay. What about displacement? Displacement from here to here, it is just barely 2 meters. So this is barely 2 meters. So if you ask me, what is the speed that will be distance traveled divided by the time, how much time I took? 4 seconds. So 6 by 4, which is 3 by 2, which is 1.5 meters per second. But if somebody asks me velocity, that will be displacement by time. So it will be 2 divided by 4, which is 1 by 2, which is 0.5 meters per second. But since it is velocity, it is a vector, I need to give direction. Can you see which direction I have moved? I have moved in the forward direction. I have moved in the forward direction, isn't it? I have moved in the forward direction. So in the positive x direction. In the positive x direction. Same thing, 2 meters in the positive x direction. So that is enough to describe the vector quantity. Yep, perfect. All right. Now, let me give you one of the most killer questions. One of the most killer questions of distance and displacement. Okay. Ready for it? Ready for it? So there is a wheel. Very few people will be able to do this, guys. Let's see how many of you will be able to do this question. So there is a wheel, okay? And that wheel is going to rotate. The wheel is going to rotate first half a revolution and then complete revolution. So it has moved. So it starts from here. So this is where it starts. It rotates half a revolution, and here by the time it comes, it does a full revolution. It does a full revolution. Consider the following points: point A, point C, point B. Okay, point A, point B, and point C. Everybody is able to understand this: point A, point B, and point C. All I want you to tell me is how much is the displacements of the points A, B, and C separately, given that the radius of the circle, is R. The radius of the circle is basically some R that is given to you. Okay, so think carefully. For half a revolution, how much displacement? For one full revolution, what is the displacement? Okay, so you need to tell all those things. For half a revolution, how much will A move by? For full revolution, how much will A move by? For half revolution, how much will C go by? How much will it go for full revolution? Same thing for B, for half and for full. Very interesting question. Okay, can you use Halliday and Resnick for JEE preparation? Definitely you can use it. It's a very good book. Please use it if you have that time and if you are in 11th standard. But if you are in 12th standard, avoid that because you have limited time. When you are exploring it, it is very nice. You have time. It's good book. Okay, let's understand. First of all, tell me one thing. When you complete a revolution, when you complete a revolution, how much will you actually move? How much will you actually move horizontally? Well, I think it will be exactly the length of the circumference. If I move like this, if I roll this wheel like this, when it rolls, the amount which it translates will be exactly the circumference. Are you able to visualize it? Just think as if somebody had painted the wheel from the outside. So if you roll it, that paint which is there on the outer surface will exactly come and it will print itself on this ground, on this table, on this horizontal surface. So this entire circumference will get printed on this white line, which will be exactly the circumference after exact one revolution. Yes or no? So can I say this entire distance from here to here, this entire distance from here to here is nothing but 2 pi r? It is nothing but 2 pi r from here till here. So if that is for full revolution, how much will it be for exactly half a revolution? Can you guys quickly think and tell me how much will it be for just half a revolution from here to here? Obviously, it will be just pi r. It will be just from here to here, it will be pi r. Yes or no? Very good. So I think I have started with at least one part in that entire table, which is C. So for C, I at least know the answer. So C is there, then B is there, and then A is there. Then you have half revolution, and then you have full revolution, right? Okay. So let me start filling up the table. For C, in half a revolution, that C point will be here only. How much will it move? It will just move exactly pi r. That same point C after full revolution will be here. Can you see the displacement? How much will it be? It will be exactly nothing but 2 pi r. Yes or no? From pi r it will go to 2 pi r. That is for point number C. Okay, now let's think about point number B. B will be simple, little bit simple to understand. Just visualize this. In half a revolution, where will my point B be? Where will this point be in this half a revolution? This point will come exactly diametrically opposite. So won't it be here, guys? Won't this point B be exactly over here? Point C would be here, exactly on the opposite side. And point A would have come over here. Point A would have come over here. So can you now think how much is the displacement of B point? How much is the displacement of B point? See, this much distance plus this much distance plus this much distance. This much is nothing but r. This much is nothing but pi r. And this much again is nothing but r. So how much is this total distance? R plus pi r plus r, which is 2r plus pi r, which means it is r into 2 plus pi, my dear warriors. R into 2 plus pi. So for half a revolution, it is nothing but r into pi plus 2. That is for point number B. That is for point number B. Exactly. But what happens after full revolution? That point will be over here. That point B will be back over here. So now, if this much length is 2 pi r, if this much is 2 pi r, even this is 2 pi r, 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 everything corresponding to the same point, the topmost points, the difference is 2 pi r. This is also 2 pi r. This is 2 pi r. This is also 2 pi r. This is 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 2 pi r. If you go to the same point after full revolution, exactly they will be separated by 2 pi r. So hence, this will be nothing but 2 pi r. Till this point also absolutely clear. Okay. So that also means point A which is there, if this is point C, point A will be here now. How much will A have moved? A has gone from here to here, which is exactly this distance, which is also this distance. Same distance it is. Same distance it is. That means this is also going to be 2 pi r. Everyone understood till this point? Absolutely clear? Okay. So now the only point remaining is this point A for half a revolution. If you can give me this answer, IIT seat pakka. IIT seat pakka, guys. Let's see how many of you can answer this quickly in the chat box right away, right now. Yeah, definitely. JEE aspirant JEE aspirant 1508, definitely, man. But you need to be regular, sincere, every day, work hard. It is possible. Okay? It is possible. You have time and follow the series properly. Good evening, GV creatures. Okay. Well. It's very interesting, guys. If you notice that point A, where it has gone, see, it has gone here. So technically, it has gone like this. Oh my God, point A has gone like this. So, how much is the base and how much is the height? Lot of you, come on, guys, you would have got confused by now. See, point A was here, point A is here now. So, this is the displacement. Lot of you are thinking it is pi r. No. So, this is the displacement. This base, this much, this base is exactly pi r. So the base is nothing but pi r. Okay. What is the height then? What is the height? This is r, this is r. So this height will be the diameter, which means it will be 2 times of r. So what is this displacement going to be? Use Pythagoras theorem. Displacement will be root of pi r square plus 2r square. So r square is common. We have pi square plus 4 and this entire thing is in the root. So r can be taken out and we just have pi square plus 4. So hence the answer will be r, the whole thing under the root with pi square plus 4. That is the answer. Root will come because of the Pythagoras theorem. Lot of people make that mistake. Got it? Everybody? Isn't it a brilliant question on the displacement part? Yeah, isn't it an amazing question on the displacement? Yeah. So if you notice what has happened, see, when the wheel rotates, this point will go on the top. That point A will go on the top. So if you ask me the displacement, displacement is this straight line. Displacement is this straight line which joins the initial location to the final location. Now to find this, what do I need, guys? To find this, what do I need? I need height and the base. You can see a imaginary triangle getting formed over here, which is right angle in nature. This is the hypotenuse. So how much is the base now? The base is exactly going to be this distance, which is nothing but pi r. We have calculated that before also. Here also it is there. So the base of the triangle is basically pi r. What about the height, guys? It is r plus r, which is the diameter, which is nothing but 2 times the radius. So now this displacement, which is exactly this one, will be this square plus this square, whole thing under the root. So r square is common. So I took common. Pi square is there here. 2 square is 4. So r square under the root will become r, and the remaining thing is as it is. So that is the displacement of point A in half revolution. Got it now? Yes, Abhijit? Everyone? Amazing, Azad? Rock? Understood? Clear, Ravi Kumar? Yeah? Why it is like this? Brilliant question. Very good. Very good. Awesomeness. Now that was basically a displacement. Let's do a question on velocity now. Let's do a question on velocity also. It's amazing. Look at this now. Look at this. Okay. This is our next example. Very good. Am I correct? Yes, JEE aspirant. Yes, correct, 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 correct. But you put 2R, that 2 should not be there. Only R should have been there. Okay. That is the only mistake I think you did. Okay. Now, a car travels, a car travels half the distance, half the distance with 2v speed, and in the remaining half distance, for half the distance it travels at v speed, and remaining at 4v speed. Find the average speed. This is a good question. This is a very good question. We need to understand it. We need to basically understand what is happening. Okay, let's see. So there is a car which is traveling half the distance with 2v speed. V is some value, variable. Answer will be in variable. It will not come in number. Okay. And that remaining half, that half of that half, it travels with v, and the remaining half with 4v. I think the best thing to do is draw a diagram. Best thing to do is to draw a diagram. So let's draw a diagram which will help us with the problem. So this is some distance which it travels, and how much speed it travels? It travels with basically 2v speed from here to here. Okay. Then the remaining half which is there, that remaining half which is there, the half of that remaining half, in that remaining half of the distance, for half the distance in that, that means maybe just this much, just this much. It travels with v speed. That car travels with v speed. And whatever is remaining over here, that same car travels with 4v speed. Are you now able to visualize this? Are you now able to visualize this, everyone? Okay. So, best thing to do in this question, I suggest, let's assume this distance as x. Let's assume this distance as x, this much. So, this will be also x. So, this total will be basically 2x. And this is exactly half. And this is also half. So, essentially, this will be also 2x distance. Everyone with me on this? Okay. So, this much is basically x. That is what I have assumed. Now we want to find the average speed from here to here. So if I want to find basically the average speed, average speed, it will be nothing but the total, total distance, total distance upon the total time which I have taken. Now distance is very simple. 2x and 2x together will make it nothing but 2x plus x, which will make it nothing but 4x. The problem is I don't know this time, and this time. That is the problem. So time from here to here may be t1 plus time from here to here. I do not know that. Let's say t2 plus time from here to here. I don't even know that. So that will be t3. So that is the main problem. So I need to figure out what these times are. But before that, on the top 100%, I have 4x in the numerator. Now, what are these times? Can we use some logic? Maybe. I just gave you the formula for distance, speed, and time. Speed is distance by time. So, what will time be? So, what will time value be, guys? Time will be distance by speed, yes or no? If you take time on the top, speed will come over here. So, time will be distance by speed, yes or no? So, let's use that concept now. So, if you go from here to here, the time taken will be the distance, which is 2x, divided by the speed, which is 2v, which is basically x by v. Okay, everyone with me? Because time is distance divided by our speed. Time is nothing but distance divided by our speed. Very good. What about here? From here to here, what is the time taken? T2. Let's think about it. Distance and speed. Distance is nothing but x. What is the speed? It is v. X by v. X by v. Okay, perfect. That is also done. What is this time? Final time from here to here. Distance is x. Speed is nothing but 4v. Oh, sir, we got everything, sir. Let's substitute. Perfect. Let's substitute, guys. So first number T1 is nothing but x by v. The next number is also x by v. The last number is x divided by 4v. I have an idea. First of all, let's cancel the x. Let's get rid of x. Just like in real life also, you should get rid of x so that you can live in present. Yes? Okay. So we have something over here. So let's take the LCM. We have to take the LCM. 1 by v, 1 by v, 1 by 4v. LCM will be nothing but 4v. So here we'll have 4, here also we'll have 4, and here we'll have 1. So what will this become, guys? 4 divided by 4 plus 4, 8, 8 plus 1 is 9. So 9 divided by 4v, right? But I know I can take that 4v on the top. So it will become 4 multiplied by 4v, whole thing divided by 9, which is nothing but 16 times v divided by 9. That is your average speed. That is your average speed. 16v by 9. We got the answer. Yep. Yes. Perfect. Everyone? Everyone? Yes, 16v by 9. Very good, Azad. And everybody else also, I believe. Yes, you got it right. Perfecto. Perfecto. Race Me King, J aspirant, Azad. So many of you. Some of you made mistakes. Yes, RMP, that is the correct answer. Awesomeness. Awesomeness. Kudos to all of you. So that's how these questions are in kinematics. If you draw the diagram, if you understand what is happening, if you assume something, eventually it will get cancelled out. You don't have to break your head. Sir, I assumed X, sir. What is X? Not given. Don't worry. Things will get cancelled out. Just trust in the process. Go in the flow. Just proceed ahead. When you take those steps only, then you will start seeing the final outcomes. In the first step only, you will not see what is going to happen in the end. You might not know what is going to cancel. Assume maybe it will cancel. If it does not cancel, maybe we need one more equation or solve it in some other way. Yeah. All right. Ibu, no issues, my dear. All right. Next. The next thing is how quickly the velocity changes. How quickly the velocity changes, and that is nothing but your acceleration. That is nothing but your acceleration. Acceleration is how quickly how quickly velocity velocity changes. How quickly velocity changes. So it's a scalar quantity. It's a sorry, my bad. It's a vector quantity. It's a vector quantity. It needs magnitude and direction both. And the symbol for that is a bar, and it is nothing but how much is your change in velocity, the whole thing divided by the time that you have taken, divided by the time that you have taken. So if my final velocity is v and my initial velocity is u, v minus u is the change and the time taken will be t. This will be my acceleration. Some people also like to write it as delta v. Delta means change and upon time. That is also fine, or this is also fine. It's one and the same thing. Okay, so acceleration is how quickly your velocity changes with the time. The unit of acceleration is meters per second square. How many meters per second square is it going to change by? It's a vector quantity. All right. Now, let's look at some questions so that you are able to see what the acceleration is all about. Let's take up some, easy, then some difficult questions. I'm going to give you some scenarios, and in every scenario, you are going to tell me what the acceleration is. There is a car over here. It was going like this at 5 meters per second. After some time, the speed has become 11 meters per second, and the the time interval over here that it took, the time interval that it took from here to here is, let's say, 2 seconds. Then the next example, over here, there is a car which is going at 2 meters per second. After some time, the velocity becomes, let's say, 6 meters per second, and the interval that it took was, let's say, 3 seconds. Okay, or let's say it took 4 seconds. Let's say it took 4 seconds. Okay, this is another scenario. Another scenario over here where our car was going like this at a speed of 7 meters per second, and then the velocity becomes 4 meters per second, and the time interval that it took was, let's say, 3 seconds. 3 seconds. Okay. Then another example where the car was going like this and it came over here. The speed was 10 meters per second, and now the speed became 5 meters per second. Let's say the time interval was 2 seconds. And then we'll take more examples like this also. Say car was going like this with 4 meters per second, and after some time the speed is 4 meters per second only. So the time interval that it took was, let's say, 2 seconds. So what is the acceleration in this case? Okay, come on, let's see. In all the scenarios, what are your answers going to be? First scenario, here, if you look at the acceleration, it is final minus initial. Final is 11 minus initial, which is 5, divided by the time interval, which is 2. 11 minus 5, that is 6 by 2, which is 3 meters per second square. In this scenario, acceleration will be final velocity -6. Why -6, my dear students? This side is negative, that side is positive. We have to choose a sign convention. That's very, very important. Okay. Otherwise, everybody can give any signs. So this side, let's take it as positive direction, x-axis, and obviously the other side will be the negative direction. This side will be nothing but the negative direction. Is that okay? So anything on that side will be negative, anything on this side will be positive. So definitely this will be -6 final velocity minus initial velocity, which is -2, whole thing divided by the time. So this will be nothing but -6 plus 2 divided by 4, which is -4 by 4, which is -1 meters per second square. That is your acceleration. Is that right? Acceleration is -1 meters per second square. Okay, let's go to this particular problem. Over here, acceleration will be final minus initial. So 4 minus 7 divided by 3, which is -3 by 3. So therefore, acceleration is -1 meters per second square. Let's go over here. Acceleration will be final velocity -5 minus initial velocity -10, because it is pointing in the left direction, divided by 2. So it will be nothing but -5 plus 10 by 2, which is nothing but -5. Sorry, it will be plus 5 by 2. So it will be just plus 5 by 2 meters per second square. Plus 5 by 2 meters per second square, which is 2.5 meters per second square. That is the acceleration. If you look at the last problem over here, you can see the acceleration will be final minus initial by time, which is nothing but 0 meters per second square. Everybody, how many of you got it? Very good. Some of you got it, some of you did not get it. No issues. Now comes the interesting part. Tell me, where is it accelerating? Where is it decelerating? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Out of these 5 scenarios, which scenarios are accelerating? Which numbers are decelerating? Let me see how many of you give the right answer. Situation 1, situation 2, situation 3, situation 4, situation 5. Situation 5 is simple. It is not accelerating only, it is maintaining. So situation number 5 is out of play. In fact, situation number 5 is nothing but uniform motion. Uniform motion scenario. It is not accelerated at all. It is 100% not accelerated. So lot of you are saying 2, 3, some of you are saying 1, 3, some of you are saying 2, 3 again, 1, 2, okay. Very cool. Let me tell you, accelerating in usual terms means, in physics terms means, you have to change the velocity somehow, whether increasing or decreasing. But in our sense, you are accelerating means you are increasing the speed. So, and decelerating means you are reducing the speed. So, in the scenario 1 and scenario 2, it is seen from 5 to 11, you have increased the speed. Here, 2 to 6, you have increased the speed. So, both of them are basically, accelerated motions, or basically you have increased the speed. Both of them, even this, okay, even this and even this, both of them, what will I say? You have increased the speed. Increase the speed 100%. It is very obvious. 2 to 6 is increase, 5 to 11 is obviously increase. But in this scenario, check this out, or even for that matter, this scenario, you have reduced the speed. So these are decelerated motion, retarding, decelerating, or basically reducing speed, reducing the speed. It is very obvious because 10 became 5 or 7 became 4. So now you might be scratching your head and thinking, sir, wait, my school teacher told me if A is positive, it is acceleration, A is negative, it is deceleration. Guys, if somebody has told you that, no, throw that concept out of your head. because Shreyas sir is going to tell you the truth. A is positive does not mean acceleration, and A is negative does not mean retardation. That is wrong. Completely wrong concept in physics. Got it? It is wrong. Okay. Right, right. Yeah. Today's class was at 2:15 because of the timing slash, my dear. Because I have so many batches. So, just for 2 days, I have taken the batch at afternoon time. Okay. So please adjust. Otherwise, it is going to be in the evening only. All right. So coming to the point. So how do I know from acceleration whether it is increasing the speed or decreasing the speed? Check this cool thing out. Check the sign of velocity and acceleration. Check the sign of velocity and acceleration. Velocity is positive, 5, 11. Acceleration is also positive. Here, velocity is negative, acceleration is also negative. Both are of the same sign. That means acceleration and velocity are parallel or of the same sign. If one is negative, the other one is also negative. Here acceleration is negative. Can you see velocity was -6, -2. Acceleration was positive. This was also positive, +5, +11. So then the speed is increasing. Got it? Whereas if they are of the opposite signs, check this. Acceleration is positive, velocity is negative, -5, -10. Velocity is positive, acceleration is negative. That's it. So acceleration and velocity are anti-parallel, or opposite signs. They are of opposite signs. Then you can say the speed is reducing. Is this now clear? We'll come to instantaneous acceleration, etc. later on in that actual chapter. But today, I want this doubt to be absolutely, absolutely clear. Everyone? Pakka? For sure? Very cool. Very cool. Awesome. Awesome. I'm going to ask you a killer question now. Is it possible? Number one, acceleration is 0, but velocity is not 0. Number two, acceleration is not 0, but velocity is 0 at an instant. At some instant, acceleration is there, velocity is not there. Acceleration is not there, but velocity is there. Which of these two scenarios are possible, or both are possible, both are not possible? What do you think? Jogi, it is evening. Good evening. Sir, will velocity be negative? Velocity can be positive, negative, depending on the direction. Like you can see, here the velocity is towards the right side, so positive. Here also it is positive. Here and here, velocities are negative because of the sign convention. So everything depends on our sign convention. What direction you assume as positive and negative. Is that clear? Okay. So many of you are saying first is possible, second is not possible. Is that true? Pakka, guarantee, lock, answer. Okay, let's see. Acceleration is 0, but velocity is not 0. This is 100% possible. I mean, look at this. I'm traveling with a certain speed and I'm maintaining that speed. What if my speed is, example, 5 meters per second and constant? And if it is constant, so then my acceleration will be 0 because I am not accelerating. My speed is not changing. So 100% this is possible. So first scenario is definitely true. Now you might be wondering, what about the second scenario, sir? Well, let me show you a very interesting scenario. Imagine you throw a ball up like this. As it goes up, the speed reduces and becomes 0 before it turns back and again falls with an increasing speed. Just consider the topmost point, which is exactly this one. At the top, the velocity is 0 for that moment. But does it stop accelerating? Acceleration, but acceleration due to gravity is still there. Acceleration due to gravity is still going to be there. So that means acceleration is going to be g, which is not 0. G is acceleration due to gravity, which we'll be learning, or you might have seen it before, 9.8 meters per second square. So at this point, that moment, it just stops, but it is having its velocity change, and it changes. In fact, next second only it gathers velocity. So yes, even this is possible. Even this is possible. Everybody with me on this? Understood? Absolutely clear? Amazing, amazing. So now I'm going to give you a nice homework question. This is your homework question, guys. You are going to post the answer in the comment section. You are going to post the answer in the comment section, and I will see how many of you answer it next time. My next class, I'm going to open up the comments over here in the live. Okay, you want to see all the students so that I also get to know about you, because you're going to stay with me for the next 2 years. Here is the question. The question is as follows. A car going towards the right side with, example, 30 meters per second turns back with the same speed in 4 seconds. Question is, find the acceleration. Find the acceleration. Okay, that is the question. No options given. You put up the answer in the comment section. Okay, so I want all the answers. Answer in the comment section. Answer in the comment section. Okay, everyone, put the answer in the comment section. Very good. Yes, perfect, perfect, perfect. And those of you who are also wondering, sir, I just saw some comments, sir, do we have something for 11th standard? Do we have a batch? Definitely, we do have our long-term batches as well. In many of our offline centers which you have visited, the batches have just begun or about to start. In fact, Vedantu is there in so many cities, and we have the pro batches for JEE mains plus advanced, and you are going to have the best teachers in these pro batches with digital classrooms, smart clickers. You are going to get, all e-libraries, libraries for studying, places for properly asking doubts. There is doubt counter, there is a student academic mentor. You are going to have, recordings of the class even in offline batch. So if you miss the offline batch, there is a camera which records everything, and also the notes which are being written down by the teacher in the boards, smart boards, that is also given to you. So these are high-tech smart classes, and you also get doubt facility at home. In case you have anything, you get dedicated parents app. You have a student dashboard where you can track your progress and how you are participating in the class. You can compete with your friends. It's fun. So many centers, and one of the newest centers being in Bangalore. Yep, in Bangalore, we have opened it at JP Nagar last year only. All right. Tamil Nadu, Andhra, Telangana, Punjab, Maharashtra, Delhi, Bihar, Odisha, Rajasthan, Pondicherry, Karnataka, Bangalore, JP Nagar, New Center, and UP. So if you are in one of these cities, please go ahead, check it out, because scholarships are also there up to 90% if you write the examination at the center, or you book a visit and just write the scholarship admission test, and you can avail that scholarship. That big discount is waiting just for you. Okay, so check it out. The link is there in the description box, and do not forget to like this particular session in case you have forgotten to do so. So you can see the link is there right over here. Explore our offline centers, book a visit right now. Click on this particular link, enter your name, details, grade, which city, and you can book a visit to the nearest center. And some of you will be like, sir, I don't have a city center near me. I'm very far. I'm in a different town or city. No, don't worry. We have the online batches as well, which are just like our offline batches, except for that you are not going to visit any center, but it feels like an offline center. So the pro batches link is also there. You can create an inquiry by filling up this form, which grade, which year, which board you are in. Accordingly, we will guide you. This is just for counseling purpose. It's up to you whether you want to join or not join. Okay, so you can fill up these forms. The links are there in the description box. I hope you enjoyed a lot, and I hope you learned a lot in this basics of physics kinematics class. I'm going to build up your basic foundation so that when you start with chapter 1, lecture 1 in 11th standard, you are not out of place and you are up to speed. Okay. So these classes obviously are like a foundation basic level. Some of you might have already studied it, but when we start with chapter 1, we are going to go in full speed. All right. So take care, guys. See you in the next class and stay tuned for all the sessions on the Vedantu JEE English channel. 6 o'clock, 11th standard, 8 o'clock, your 12th standard class. Okay. Bye bye.